starting a little late. Hello, hello. Oh, good, you're not dead. It's preferable to have a live audience. This is an interesting microphone. It's kind of intimidating. Anyway, so my name is Bruce Payette. I've worked on PowerShell since longer than Jeffrey has worked on PowerShell for a very strange reason, but that's all in the history of PowerShell. And today I'm going to talk to you about debugging. Jeffrey talked about things like the fancy new transcripting and so forth. I'm not going to cover that. There's a separate security talk where I think a lot of that stuff will be covered in depth, but obviously it's useful for debugging things. First things first, in the list of countries, Tobias missed one. Both Lee Holmes and I are from Canada, so I'm now virtually holding up our flag. Okay. So overview, introduction, what I'm going to talk about, and then the various types of debugging. Interactive debugging, most people are familiar with that from the ISE and hitting F9 and breakpoints. You can do it from the command line, so we'll look at a little bit. The command line debugger is far more powerful than the ISE debugger. And June is waving, going, yes. Static analysis, which some people don't consider to be debugging, is something that is very much possible since version 3. Unit tests, again, something that people don't think about very much. Again, I won't talk about that since the unit test stuff will be covered at length by June. And then finally, we're going to go into lights out debugging and the non-PowerShell host debugging, which is a lot of the stuff that was introduced in version 5, and then conclusions and questions. So, what is debugging? It's finding and fixing flaws in your code after you're done, after you've written your code. It may be immediate, where you're doing interactive development, you write code, you test it, and then you spend a bunch of time finding and fixing the bugs in the code that you wrote. Languages can provide a certain amount of assistance, helping you prevent some really obvious errors, incorrect variables, and so on. C# does a really good job of that. A lot of the time, a C# program, the first time you run it, it'll almost work. And so I wanted to raise something, again, that Jeffrey mentioned. In PowerShell 5, when we did classes, we looked at C# as the model. And so the semantics of classes are much more strict. If you say you're going to return something, then you must return something. The only way to return something is to return it. You can't just write to the output pipe, because there is no output pipe in a class method. If you use variables that are non-initialized, then you'll have to fix that. And so there's a lot of stuff in classes that allow you to write programs instead of scripts. And so I'd say a big transition for PowerShell version 5 is moving from a shell and scripting language to a full-fledged programming language. And I highly recommend, if you're going to write anything of size, then you use classes. And of course, debugging doesn't end when you've, quote, finished your code, as I'm sure we all know, especially with DevOps, right? Because now you're the guy on the beeper, right? Your code goes into production, but you put it into production. And then if something goes wrong, it's a live site issue and they call you. So you're really incented to make sure that your code works properly. So when you're thinking about writing your code, think up front. Think about how are you going to debug it when it's being deployed in the field. So interactive debugging, the original PowerShell v1 debugging feature was set debug -trace 1 or 2, where we would give you a list of all of the statements being executed. It wasn't terribly interesting. A number of people, though, were able to use that debug stream to actually do like breakpoints by not responding to the call to set debug until you hit step next. So it's debugging the ISE, we've done that. One of the things to talk about with the way debugging is implemented in PowerShell that has an effect on things. So PowerShell, if you're a Lisp developer, then you'll be very familiar with how PowerShell does debugging. It does a it recursively enters the interpreter. And this had an impact on how we design classes. There are no private fields in classes, because if you were in PowerShell and they were private to PowerShell, then they would still be invisible in the debugger. And so we've added this ability to make class hidden. So the interface is publicly visible, but you can still see the things that are part of the implementation. And we think that'll work out really well. We don't have any evidence to support that. The downside of not being at the podium is I can't reach the water. Pardon me while I make horrible faces and groany noises. Brilliant. So let's do a quick little demo of some of the command line debugging. So this is a bit more advanced than a lot of the stuff. I have my program here. It doesn't do very much. It just iterates through a list. Oh, well, that kind of sucks. Yeah, well, that's because Office is very clever, and it splits your screens automatically. So, yeah, there's this feature bug thing that is never very clear. I do indeed. And I don't get my little... Yeah, there's a bunch of controls that are missing, so. This is a large, well, this is a relatively recent build, so it has issues, many issues. So we have a little function at the top, foo, and the particular thing that we want to debug is when the value of sum is greater than 8, I want to print out what it is. And so how do you do that in the ISE? You can't, right? All you can do is stop on a line. Which means if you're waiting for a particular instance in a loop to occur, you can be pushing like go a lot. So here what we have is we're setting a breakpoint variable, or breakpoint on a variable. When that variable is written, we'll perform an action. The action takes the form of a script block, and in this case, it's getting the command, right? So again, reentrant interpreter, yes. Okay. Yes. Yes. So if you can't see it, let me know, and if I'm talking too fast, throw something at me. Okay. Yeah. He's ready. Right, so because it's a reentrant interpreter, it's actually in a different scope, so I need to look up the scope stack to retrieve that variable that was in the scope of the calling function. So I grab the PS call stack, I grab the call stack, I extract the variable I want, and then I can do a test for $sum. And if it's true, I'm going to write out a message. And then I'm going to get rid of the breakpoint because I only want it to fire once. Right, so this is a very specific condition. You can be as complicated as you want. We run it, and look, we get a little green message, wow. But this is a very, very powerful technique because you can do things like logging the state of the variable. Every time the variable gets written, you can see what's being written to the variable. Every time it gets read, you can see that it's being read. Every time it's being read, by capturing the call stack, you are able to figure out who called it. Right? So you can do very sophisticated, very detailed debugging on PowerShell scripts using the command line debugger, as long as you know how. It's not particularly difficult. There's a few commands to know. Get call stack is pretty much the most important one, and writing script blocks. I highly recommend that if you have a tricky debugging problem, that's something you consider doing. So back to the presentation. So, I hate Office. I didn't say that. Nobody heard that. Okay, we're back. And it's split the screen again. No, it hasn't. Now I have no idea what it's doing. Pardon? Yeah, where's that? Yeah. Yeah, well, it's split again. So let's go back a slide or two. Yeah, so that's interactive debugging. That's not the form of interactive debugging that you're used to, but you're getting a response in real time. And just for Tobias, there was a demo that I wanted to do. So looking inside modules. When you're debugging modules, the scope of the module is not normally visible. And it's only visible while the module is loaded. It's only visible. So there need to be some tricks to doing debugging. Right? I said with classes, you don't have hidden members, or well, you have hidden members, but you can still see them by forcing looking at them. That's not the case with modules. And so when I implemented modules, I made allowances for that by allowing you to invoke commands in the context of the module. And this is fairly straightforward. You need to get an instance of the module, and then you can use the ampersand operator. My voice is now going, whatever. But you can use it to invoke in the context of the module. And so here I want to see what functions are available inside the module. I run the first several lines. I get a small set of functions. But let's see what happens if I actually run it inside the module. Ah, there we go. Better? Yes. Yay, my touchpad is working. Right, so in this case, the first step I do is grab the module context, and then by using ampersand, I can evaluate the script block in that module context, which is a little weird. Let's run it. And so there's rather more functions, right? So now I'm seeing all the private functions of the module. So what it's doing is, there's a script block, there's a module object, and a script block, right? And the call operator. Yeah, the call basically means call the script block in the context. I had hoped at some point we would also be able to do remoting. So if you had a remote session object, you'd be able to invoke a script block in the remote context using the same syntax, but we never got around to it. Okay, so and since the script block can contain anything, you can go in, you can look at the module scope variables, you can manipulate the module scope variables, you could already set breakpoints in the module. So you have a lot of flexibility. Obviously, just to be clear, if you set a breakpoint in the module, you will be in the module scope, right? So you don't need to do this funny thing. It's only if you're trying to write scripts that do interactive debugging, which is like an oxymoron. Almost worked. So that's it for the interactive debugging using the command line debugger. Static analysis. So static analysis of code using the tools. With version 3, we introduced the AST. The AST has been improved subsequently. We also added set strict mode in version 3, which primarily it does runtime analysis. Like variable unsat property does not exist. But it does a little bit of static analysis as well. There is in fact a proposal, there's an RFC out. We now have an RFC process for PowerShell. There is an RFC out to change this from being a command that's only run at runtime to a keyword that is executed at compile time. So then we'll be able to do all the static analysis and generate errors at compile time. Feel free to jump into the RFCs. They're off the GitHub. If you go at GitHub PowerShell, I think it's RFCs, you'll find all those documents. And we're open. We have all the RFCs that are up there have been proposed by the PowerShell team, but we're happy to take RFCs from anybody else. We want to follow a lot of the patterns that Python and Ruby and probably not Perl, but. So with the AST made script analyzer largely possible. Jeffrey alluded to this. You can catch a bunch of problems by running static analysis. I had a question mark in the demo. The demo was very short, but nothing is fast because I have to keep changing screen modes. So here are all of the node types that are now in the ISE. I wanted to call out two, or no, in the compiler. I wanted to call out two. So in version 4, we used some magic to rewrite the parse tree to handle dynamic keywords. And so where it saw a dynamic keyword, it would rewrite that parse tree node into a regular command node. So you lost information about what it actually was. So Jason introduced a new node type, dynamic keyword statement. So now the AST has full fidelity with the source code. That's definitely a good thing. So if you're looking for a particular type of AST, you have a wealth of choice, good or bad. Right. So I'm going to get a few shortcuts here in my demo. The command AST, and then a function definition AST, which I'm going to look for. Here's my script block. It has two functions, F1 and F2. And let's execute the first bit. Let's try to execute the first bit. Right. So the purpose of that command, if you take a look at it, is from the script block, I extract the AST. This is true on every script block. It is really quite amazing. You can just dot your way through the AST because IntelliSense will give you each step. But beyond a certain point, I didn't want to do the exact search for a specific node. I just want to find all the nodes that are function AST nodes. And so I use find all, and that will iterate through all of them. And every time it hits one, it'll call the script block, which just takes the form of a lambda, really. And you can say whether you want to recurse like if you're inside a function, do you want to go inside the function? And then I want to extract the name. So with one line, I can get a list of all of the functions without doing any text processing whatsoever. Yeah, so what it does is it iterates through the tree, looking at every node and comparing it and running the lambda against that node. So the lambda forms a condition. If it returns true, then that node is emitted. And in this case, if it's a function AST, then I take the name of, and there's a little bit of magic here. So what find all does is find all returns a collection, right? But I didn't want to do a for each because I'm lazy. So I'm taking advantage of a feature we introduced in version 3, where if you apply a property reference against a collection, if that property isn't on the collection, then it automatically iterates through all the members of the collection. And so that saves me a whole lot of typing. And I see Cyril like, what is he talking about? But again, it deals with our cardinality. There are a lot of functions that might return a scalar, or they might return a collection. And by doing this, it gives you uniform experience, especially with workflow. So this is the second one. Well, she jumped to the last thing. Ah, yes. So because all commands have begin process and end blocks in the AST, a normal command invocation, one that's not in a pipeline, defaults to the end block. This has always been true. This is true in compiled commandlets. If you have something that doesn't do any stream processing, then you can do it in the end block. You can also do it in the process block because there is a tweak where the process block gets called once before the end block. The effect is the same. In the case of the compiler explicitly puts it into the end block. So when you walk into an AST, you walk into the AST, and then because it's a command AST, you have to get which part you want is the end block. And then the end block will be composed of a collection of statements. You can go through the collection of statements, and then each statement will be, command or whatever. And here we're going to try and find, this is actually kind of a useful one. We want to find all the command invocations for which there is no definition. So again, we get a list of all the commands that are called. Oops, I better run that part too. Right, so this extracts all of the invocations. So the first one extracted all the definitions. Now we're extracting all the things that we called. And then for each thing that's called, if it doesn't exist, and it's not in the defined functions. So that's one of the tricky things, is that when you're editing your script, you're defining functions, but until you run your script, the functions don't exist. You can't do get command on them. And so this merges the things you can do get command on and the set of functions that were defined in this script. And after all that effort, we find that F3 is called. There's no definition for F3. So this is a bug in your program. You've now debugged your program. Go and implement F3. Right. So that was the demo of the AST. Let's go on to the interesting stuff now. Testing. I'm not going to spend any time on this. Testing isn't like, the old thing was, isn't that a dev thing? Why should I write test suites? I think everybody understands now why they should write test suites. Unit testing, we need to have a unit test framework. I think it was incredibly smart of Microsoft to, rather than invent its own, adopt the dominant test platform, support it, and ship it in Windows, which if you've been in Microsoft 5 years ago, your head would have exploded at even suggesting that. It is absolutely amazing. It's a great framework. It does mocking. It does all that wonderful stuff. June will share all of her secrets with you. Now, this is the one where I want to spend more time. Interactive debugging of non-interactive applications. This is the stuff that was added in version 5. And what's so special about this? Well, in a non-interactive application, you can't interact, right? There's no console, there's no place to type commands. So how do you do that? Even the transcript stuff, if there's no console, then there's no console transcript. And the trick is the same thing that you would do with Visual Studio, is that you attach to the process. And this is where get the PSH host comes to your rescue. Let's do the painful switch back to the example. So I've written a small C# application that loads PowerShell and runs PowerShell. It's not using any of our host technologies. It's not running in WSMan. It's not running from the console host or ISE. This is a completely standalone sort of a service host type of thing. And let's start it. Actually, before I do that, well, and this is an annoyance in how all of this works. right? So it has a simple ARG cracker. One of the things that's annoying about the way the debugger was implemented in version 5 is that if your program is already running, you're too late. You can't cause it to break, at least not through the obvious mechanism. I think there's a secret trick I can use to do it, but I haven't had a chance to try it yet, so I'm not going to tell anybody about it. So first thing I do is I do -debug. And you'll see the same thing with DSE. You have to start DSE in debug mode. And this will cause it to stop. And now we'll run it. And we'll go back to our host. Right. This is the new commandlet in version 5. It finds all of the things that are hosting PowerShell. Right? So PowerShell ISE, I have an instance of that. And then there's a bug in this version where it always resets everything in the console. Better? Okay. So you see all the various instances. WPSH is my program being run from Visual Studio Host. And it tells you process ID, it tells you the app domain. Who knows what app domains are? Anybody? Jeffrey? Yeah, so it's a .NET feature. In theory, it was supposed to allow you to do multi-tenant by separating .NET applications into isolated bits. In practice, it didn't work very well. It's useful if you want to unload DLL. That's the primary value that it provides now. Normally, the only way to unload a DLL from .NET is to unload your assembly, or unload the app domain. So if you want to do that, like we use it in some of the assembly cache analysis, because we have to actually load some assemblies, do the analysis and then discard them.